Day 6, the last section of this unit. Parallel lines and proportional parts. The triangle proportionality theorem. If a line is parallel to one side of a triangle and intersects the other two sides, it divides it proportionally, or divides the sides proportionally. So we've kind of talked about something like this similar before. We talked about the mid-segment. But the thing about this is, this line that is parallel to the side, well, let's draw a better one that's actually going to be parallel. This line does not have to be at the midpoints. It does not have to be a mid-segment. It can be anywhere along here. And no matter where it is, as long as it stays parallel, it cuts, divides the legs, the other two sides, proportionally. Okay? So for example, AD is proportional to AC the same way AE is proportional to, sorry, I'm going to do DC here. We'll get into all the different variations. The same way AE is to EB. They are proportionally cut. And once again, no matter where this line is, if I put new letters here, R and S, or here, or here, or here, we would still have the same proportionality of the parts. So let's look at this a little bit more in depth. CD, which is right here, I kind of alluded to this already, is proportional to DE. The same way CG is proportional to, right there, GF. ED, the lower portion, is proportional to FG. The same way GC is proportional to DC. And if you look, we've talked about rewriting these. CD to DE, right? CD to DE. So it's really the same thing. And then CF, here, on the diagonal, we're talking about CD. So CF, the whole thing, is going to be proportional to CG. The same way CD is to the whole thing CE. And we kind of had a problem like that in yesterday, day 5's work practice. Okay, so if PS is 12.5 and SR is 5 and PT is 15, and we're trying to find TQ, we can say 5 is to 12.5 the same way X is to 15. So 15 times 5 is 75 equals 12.5x. And then if we take 75 divided by 12.5, we get x is 6. Now watch. This is also 17.5, correct? And this, before we knew it, what now we know it's 21, was 15 plus x. We could have said 5 to 17.5 is more complicated, but this is the way your brain processes it. X to 15 plus x. x equals x plus 17.5. Sorry, x times 17.5x. I don't know what I was thinking there. Subtract 5x. We get 75 equals, okay, look at that, 12.5x. Look familiar? It ends up being the same problem. So just different ways to prove the same thing. Example 2. Again, you could look at this as one big fraction mark. X over 16 equals 5 over 10. 10x equals 80. X equals 8. Also, if you notice it, 5 is half of 10, 8 is half of 16. That would have been the shortcut. It's a 2-to-1 ratio. If you see these things, it's okay. This also works the opposite way. If the sides are proportional, then the lines are parallel. So it says in DEF, that is the big triangle, EH is 3, HF is 9, DG is 1/3 of GF. So this is, whatever this is 1/3 of it. Are DE and GH parallel? Yes, they are. Because what's 9 divided by 3? 3. What's 9 times 1/3? 3. So if this is 3 times this, and this is 3 times this, then we have parallel lines here. Now, 3 parallel lines intersect 2 transversals. They divide them proportionally. So, for example, AB to BC, DE to EF. We could also say AB to AC, the whole thing, equals DE to DF. And again, you can go upside down, you go FE to ED and FE to DF. All variations, but you can hopefully get the general idea. We'll work on this more in class. So find the value of x. Again, you can look at this as this is a fraction bar and this is a fraction bar. You have your fraction. 3 over 9 equals x over 15. Now if you see the shortcut, this is 1/3. What's 1/3 of 15? It's 5. But we can also do the work. 9x equals 45, x equals 5. Or if you think 3 times 3 is 9, what times 3 is 15? Many ways to solve these problems. Now, 3 or more parallel lines cut off congruent segments on one transversal, then the other ones are also congruent. So, we know this is the case. Now, they can all be 1, but they have to be coming at the same angle. And I want to show you why. If I have my transversal here, this segment is obviously going to be longer than this segment because it's coming in at a different angle. And it's clearly coming in at a different angle than over here. So they're not going to both be the same measurement, but this one will be equal to this one. So they don't all have to be equal, but each line will be equal. We split up itself. So given AR, BS, and CT are all parallel, and RS is equal to ST. So we mark that first. RS is equal to ST. If RS is 12, then ST has to be 12. And we know that these two have to be equal. So if AB is 8, BC is 8. If AC is 20, then AB has to be 20 divided by 2, because they have to be equal. And if AC is 10x, then BC is half of that. So again, divided by 2, 5x. And that's it.